Moving on to the calculus, the fundamental theorem of calculus says the definite integral evaluated from a to b of f of x dx is equal to capital F of b minus capital F of a. Remember, capital F is where lowercase f of x is equal to the derivative of capital F of x for all x in the interval a to b. Basically what that means is that capital F is the antiderivative of lowercase f. This fundamental theorem of calculus describes a way, the fundamental theorem of calculus describes a way of evaluating. So how we found that numerical value, it's a way of evaluating a definite integral. A definite integral just means from a specific range of values, and the range of values in this case is from a to b. So a definite integral describes a way of evaluating a definite integral, not a procedure. It's not a procedure. A definite integral, not a procedure to find the antiderivative. Remember, the antiderivative has that c value. With initial conditions, you're able to find the actual function that specifically sets or that corresponds to that set of initial conditions. A definite integral is not a procedure to find the antiderivative. We already know that procedure, but it incorporates that procedure because now we have to evaluate for numerical values. So the integral of f of x dx evaluated from a to b. Notice how I'm saying it different ways because you can say it different ways. You can say the integral of f of x dx evaluated from a to b. Or you could say the integral from a to b of f of x dx is equal to the antiderivative evaluated from a to b, which is equal to the antiderivative evaluated at b minus that antiderivative evaluated at a. This right here is big. This is big stuff right here. This is important to recognize, being equal to what I boxed in yellow. The fundamental theorem of calculus also says the constant of integration c can be dropped because this part is cool. Because let's take that capital F of x plus c, right? Notice how we didn't have the plus c where I wrote it in red. F of x plus c evaluated from a to b is equal to f of b plus c minus f of a plus c. So if I was to take that antiderivative plus that constant of integration, c, and incorporate that in, look at what's going to happen. This c minus the same exact c is going to zero out. And that is why the constant of integration c can be dropped. But constant of integration c can be dropped. And if you can't see that, I'll show you. F of b plus c minus all of f of a minus all of c. We're going to distribute that negative sign. And you can see c minus c cancels out, and we get f of b minus f of a. So it's kind of cool stuff right there. So we don't have to worry about, when we're talking about definite integrals, we no longer have to worry about that constant of integration. We do have some properties. So this video is going to include the definition of the fundamental theorem of calculus, which we just went over, and also some properties. So our properties of our definite integral, so this is definite integral properties. When I say definite integral, or when you hear definite integral, you know that you have limits of integration. You have a lower limit, a, and an upper limit, b. So when I have that definite integral of k times f of x dx, we can still take that constant k to the outside, evaluate the definite integral, and then multiply the result by k. Second rule of definite integrals, that's our integral from a to b, if we have multiple terms that we are adding or subtracting, we can evaluate them separately. So we can take the definite integral of each term separately, just like we were able to before. That's a g of x. If, now some of these, you're not going to know on number 3, number 4, and maybe even number 5. They're not typically used every time we evaluate definite integrals, but knowing them is really important. So the definite integral from a to b of a function f of x dx is equal to, we can break that up into different integrals from a to c, but then we have to evaluate from c to b. So we can break this one integral from a to b into 2 integrals or more, as long as c is between a and b. So c has to be between a and b, and then we can break it up into smaller integrals. If my limits of integration are equal, so my lower limit equals my upper limit, that definite integral value is equal to 0. And if my lower limit and upper limit are switched, they're flipped, where I take the upper limit and it becomes the lower limit, and the lower limit becomes the upper limit, that would equal to the opposite. So if I flip my limits of integration, I have to take a negative to the outside. So these are really important properties for you to know. I would encourage you to make some flashcards so that you're familiar with seeing them and knowing them and understanding them when we have to apply them, of course.